Okay, Chargers, this morning what we are going to do is focus on scale factor. So, on the top left of your Cornell notes, I want you to write scale factor, and then we will begin our lesson. First things first, we have a few new words that we need to learn in order to have this, in order to really figure out what we're doing. Our first word is scale factor, which is the number that you would multiply your original dimensions to create something new. So, for example, if I had, like we'll see next, a triangle, and then I said times 2, my triangle is going to be 2 times as big on either side. So that is a scale factor, is in the number that we scale it to be. Next, there's an enlargement. So this would be an example of an enlargement because we have created a bigger picture. It is a number that it's multiplied by a number that's greater than 1. So 2 would be a good example, or times 4, or something to that extent. Our last definition is a reduction. A reduction is a smaller picture. So let's say you originally had a picture like this, and then you multiplied by 1/3, and your new picture is only that big. That would be a reduction, a smaller picture. And we're going to multiply that by a number that's less than 1. In our case, it'll be fractions all day today. Now that we have these terms, scale factor, enlargement, and reduction, we're ready to move on to our example. Here we go, scale factor. First things first, I see a triangle on a graph. What do I have to do? If the original length was multiplied by 2, what are the new coordinates? Well, in order for me to know the new coordinates, I would need to know the length and width of my original picture. So I'm actually going to skip ahead to this next question because it's going to help me much more in figuring out what I'm going to do. So, if I look at this table here, it says actual picture in length, and then my new picture. So my actual picture is what is here. It's my original, okay? So the width or length, how long is this triangle? Let's count. 1, 2, 3. It's 3 units long. And how tall is it? The height. 1, 2, 3, 4, 5. It is 5 units tall. Now, what is the information that they told me I need in order to create a new picture? They said if the original length was multiplied by 2, and I know that that's going to be my scale factor because if I'm multiplying anything by a number to get a new picture, that's what I'm going to do. So I'm going to multiply my scale factor by both of these sides. So what is 3 times 2? 6 units. Make sure to keep your units with you. And 2 times 5 is 10 units. So now that I have the dimensions of my new picture, I can graph it. So what I'm always going to advise you to do first, particularly when we're working on a coordinate plane, is for you to first do your length and then find your height. So my length or width is 6 units. So 1, 2, 3, 4, 5, 6. So here is my length. And how tall am I going to go? 10. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to go up 10, but let's look at the image that I have here. So if its hypotenuse is this way, I want my tall one to go up here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The whole length of this side. And then I'll just connect. Okay? So we can already tell just by looking at that image that it is 2 times the size of our original image. But my first question said, what are the new coordinates for my triangles? Let's find the coordinates. This first coordinate is going to be 0, 0. My second coordinate is going to be 6, 0. And then my third coordinate for the tip of my triangle is going to be 0, 10. So I have my coordinates. I filled out my table. Let's see what else we have to figure out. What is the new picture a reduction or an enlargement? In order to find that out, I would need to know a reduction. A reduction means what? It means smaller. And an enlargement means what? Bigger. So when I made my new picture, was it smaller than the original picture or bigger than the original picture? The answer is it was bigger, which means it was an enlargement. What is the constant of proportionality? Ooh, this is a really good one. Constant of proportionality means what is the ratio of my original shape that I could duplicate it in my second shape. So my constant of proportionality here is going to be 3 to 5. So if we double this correctly, this would mean that this constant of proportionality could also simplify to 3 to 5, which it can. If we have 6 to 10, we could divide both of those by 2. Divide on both sides so that it stays proportional. Well, that's backwards. 6 divided by 2. How many times does 2 go into 6? The answer would be 3. How many times does 2 go into 10? The answer is 5. So since they share a constant of proportionality, that is a test to show that we know that they are proportional. Again, all I did was find a ratio between the width and the height of my original triangle and made sure that that was the same thing that I had for my new triangle. Okay, I think that's all we need for today. We're going to do this on grids as well as just regular pictures comparing their constant proportionality or ratio between the dimensions. Wonderful. Close your notebook, close your laptop. Let's do some practice.